In this video, we are going to work the following problem. It says the graph of f of x equals sine pi x minus 2 plus 2 to the x minus 2 plus 1 is shown below. Use the scheme described below to estimate the area between the graph of f of x and the x-axis over the interval from minus 1 to 3 and sketch the rectangles. Okay, so here's what the graph looks like. We need to write down that information. So minus 1 to 3 on our interval, delta x1, delta x2, and delta x3. We need to write down what those are. So that is 2, 1, 1. x1 star, x2 star, x3 star. All right, and those are 0, 2, and 3. Okay, so to start off this problem, what you want to do is to draw your interval first. So from minus 1 to 3. That's what that's going to look like. All right, and then draw your subintervals. So the first subinterval is 2 units wide, so it's going to be 1, 2. Starting over here on your left-hand endpoint of your interval, go 2 units, and that's where your first subinterval is going to end. All right, the second subinterval is 1 unit, so go where the first subinterval ends, and then go 1 unit to the right, and that's where your second subinterval ends, and then just keep doing that. The last one you get for free, basically. Next, go and mark your points that you picked. So the first one here is at 0. So I'm just going to mark that with an X so it's easier to see. The next one is at 2. And the third one is at 3 over here. Like so. All right, so once you have that marked, then what you want to do is to start drawing your rectangle. So I usually start drawing the bottom one. Remember, the width of the first subinterval is how wide the first rectangle is going to be. So the first rectangle is going to be this wide. And since the graph is above where the point was picked, it's going to go up like this. All right, next up is I like to draw where the roof of the rectangle is, and that's based on where the point is picked, right? So the point's picked right here. Okay, so I would go up until I hit the graph, and wherever, straight up or down, right? And that's where the roof is going to be. And so now I know where the bottom, both the sides, and the top of the rectangle are, and that means it's really easy to draw from there. So the first rectangle is going to be, oops, that's supposed to be a straight line, but it doesn't look too great. Okay, so that's where the first rectangle is going to be. All right, next up, do the same thing with the second rectangle. So the second rectangle, right, is going to be as wide as the second subinterval, so it's going to be sitting in here just like this. Okay. And draw the bottom of it, and then to figure out where the roof of it goes, right, it's where the point was picked. Okay, so the point was picked here, so go straight up until you hit the function, and it's right here. So that's where the roof is going to be. So now I know where the sides, bottom and top are going to be, so that makes it really easy to draw the rectangle in there. Same thing on the third one. So just go here, draw the bottom in. And the point I picked was this third point up here, so just go straight up. Okay. So that's where the third rectangle is going to go. All right, so that's it for drawing our rectangles. At this point, we can kind of eyeball and see like what the approximation is. It's really not too bad, right? Because this graph is drawn very nicely. We can kind of see if we start just counting these blocks in here, 1, 2, 3, 4, 5, 6, 7, and a little bit more. So we would kind of expect our approximation to be 7 point something. Okay. So that's for drawing the rectangles, and now we actually want to use our approximation, right? So we would use our formula, I equals 1 to n, f of xi star times delta xi. Remember, that is our approximation formula for this scheme of rectangles and points. We know that in this case, right, because they give us 3 widths, right, and 3 points, we know that n is 3, right, because that's the number of rectangles that we'll wind up with. Try and write this a little neater. All right, so we're going from 1 to 3. And so now it just makes sense to write this in the expanded notation. So I would plug in a 1. So I get f of x1 star delta x1 plus f of x2 star delta x2 plus f of x3 star that looks really bad, delta x3. All right, so that would be our approximation formula written in the expanded form. All right, that 3 is bothering me, so I got to get rid of it. Okay. Then we know all of these numbers. We know the xi stars and the delta xi's because that they were given to us, right? So we would just use those. So x1 star is 0. And delta x1 is 2. x2 star is 2. Delta x2 is 1. F of x3 star is 3. Times 1. Okay. All right, so now we're at the point where we actually need to start plugging these numbers in into the formula, right, into the function, to figure out how tall these rectangles are. So let's do that. So the first number that we need is f of 0. So when I plug a 0 in here, I get sine of minus 2 pi plus 2 to the minus 2 plus 1. So that comes out to be sine of minus 2 pi is 0. 2 to the minus 2 is 1 over 2 squared, which is 1/4 plus 1. So that comes out to be 5/4. So that goes here. Next up is f of 2. So plug that in. So when I plug a 2 in, I get 2 minus 2, that's 0. So I get sine 0. Plus 2 to the 0. Plus 1. So sine 0 is 0. 2 to the 0 is 1. So I get 1 plus 1, which is 2. Next, plug in the 3. When I plug in a 3, I get sine of pi times 3 minus 2, so that's sine pi. plus 2 to the 1 plus 1. So sine pi is 0, so that gives me just 3. So I get 3 times 1. All right, so just stopping here to take a look at this to make sure it makes sense, right? Remember, this is supposed to be the approximation of these rectangles. So it's no coincidence, right? This first rectangle is 2 units wide by 1 1/4 high. The next rectangle, 2 by 1. The third rectangle, 3 by 1. Okay, so these are the actual areas of the rectangles. So multiplying that, I will get 5 halves plus 2 plus 3. So I get 5 plus 5 halves. That comes out to be 15 halves, which as a decimal is 7.5, right? So that looks really good, right? That is what our eyes are telling us here. So this is how you would use the approximation formula to calculate that out.